Okay, so now we are going to see theorems of continuity. Okay. Okay. Theorems of continuity only. So here you are having actually like a few functions. Which color? This color. Okay. So you are having f of x, then you are having g of x. Okay. Here you are having f of x plus g of x. Okay. So f of x plus or minus. Okay. Can you plus or minus g of x? Okay. Here you are having f of x into g of x. Okay, and here you are having f of x divided by g of x. Okay, see, if in case mm, f of x is continuous, okay, and g of x is also continuous, then f of x plus or minus g of x will be also continuous only. 1 minute. I will write a little bit neat. Continuous, then this continuous. Okay. Okay, so then f of x or g of x. Okay, so now f of x into g of x, it will be also continuous maybe. Okay, then coming to here, f of x divided by g of x, this will be also continuous. Okay, so all of these will be continuous. Okay, this is actually a theorem. Then coming to f of x, now next case we are going to come, that is f of x is continuous. Okay, but but g of x is discontinuous, then what will you be doing? Then what is the answer for this? Okay, well, the answer for this is definitely f of x plus g of x is going to be discontinuous. Okay, but these two cases are there, right? These two cases, these can be discontinuous. This can be dis or continuous. This can be dis or continuous. It's something that we don't know. No, this color won't be visible for the camera, I think. So then color green, then brown. Okay. Then this is also going to be this. This is something that we cannot determine just like that. Then coming to next case, which is also not determinable. Okay, which is dis or continuous. It can be dis or it can be also continuous. Next is f of x. Okay, see, f of x is discontinuous. Okay, and g of x is also discontinuous. Then what about f of x plus or minus g of x? Here, if you check it very carefully, here f of x is continuous and g of x is discontinuous. So here you got discontinuous. But even though here f of x is discontinuous and g of x is discontinuous, here you cannot determine. Here you cannot determine. You cannot determine in sense you have to calculate. Okay, you have to calculate. Just like that, by thinking, even like by using this theorem, you cannot say, you have to calculate for that separately. by those formulas or by those things which I said, right, like that. Then here also you cannot determine, which is f of x into g of x, and next case which is f of x divided by g of x. There also you cannot determine. Okay, so all these concepts. Okay, so how are you going to remember them? First, just remember which are continuous. This case, everything is continuous. In case 2, okay, no. You are going to just remember which is continuous, which is discontinuous. Okay, because remembering that majority of this place is actually this. It can be either continuous or it can be either discontinuous. Okay, either or, it can be either continuous or discontinuous. So first case is fully continuous, second case is one discontinuous and another, sorry, two discontinuous, one continuous, and other than that two not determinable. By just using this theorem, you have to do and you have to see. Okay, then next concept is, okay, this is also theorems of continuity only. Which is actually a property, this property is actually based on modulus. Okay, so this property is actually, for an example, you are having a quadratic equation. Okay, see, actually till now we don't know this one. Till now we don't know, in sense I have not said this in the beginning itself, but even though we were doing this, okay, without knowing even, we were able to do this. That is, okay, so if a function f is continuous, then modulus of f is also, okay, then the modulus of f is also continuous. Also, but note, if function f is continuous and differentiable, but modulus of f need not to be differentiable. Okay, it need not to be differentiable. That you cannot determine. Okay, so for an example, I will take a quadratic equation itself. Okay, so you are having x square minus 3x plus 4. Okay, no, minus 4. Okay, minus 4. Now the modulus of this quadratic equation is going to be modulus of x square minus 3x minus 4. Okay, that's it. This is what the modulus is. Actually, the graph, okay, when you are seeing in graph, you will be understanding a lot better. Okay, so you are having graph for this like this. Okay, so this point is minus 1 and this point will be 4. Okay, this will be minus 1 and this point will be 4. When you are actually factorizing it, you will be getting it. Okay, but this is actually before applying modulus. After applying modulus, what you will be getting is, okay, the graph will automatically turn like this. See, this part is what the negative part, right? This part is what the negative part is. That part alone will be shifted towards the positive region. That means this will be like this. Oh. You got like this, minus 1 and then 4. Okay, so here you will be having like this, here also you will be having like this. Okay, just like that will be tilted towards the upwards. Okay, here what is the altitude that you are having from here to here? The same altitude will be having from here to here. Okay, just some basic common sense. Then what concept do we have else? Theorems of continuity only, but here we are going to see about a composite function. Okay, composite function. This is also theorems of. This is also another theorem of continuity, which is actually based on composite function. Theorems of continuity. Actually, okay. Continuity. So here this is actually based on composite function. So what is a composite function? I did not give you that much clear-cut explanation in relations and functions, but I did give you some explanation for that. Okay, it's not like I have not given you anything. I have given you some explanation for composite function and relations and function itself. Here a little bit we will be talking about it. See, when you are having a function inside a function, for an example, coming to oscillated discontinuity, okay, over there also we have seen sine 1 by x, okay, 1 by x is a function and sine is also a function, okay, actually it will be sine x, okay, so you can take it as sine y, okay, sine y, where y is equal to 1 by x, okay. So here when it is like this, 1 by x is also a function and sine y, okay, this is actually here this 1 by x is equal to y, like that if you are keeping now, then it will be sine y, right? So here sine y is also a function, inside that y is also a function, okay, because y is equal to 1 by x. Okay, so I have given you some basic information which little bit more clearly even I said in relations and functions. Okay, but coming to here, this case, you are having a function like f of g of x, okay, f of g of x. Here g of x is discontinuous, okay, here g of x is actually discontinuous at some point c, okay, at point c. Don't worry, we will do one sum in here also, so that it will be crystal clear for you all. Okay, at point C, because this concept is little bit not complicated, not tricky, it's kind of long, okay, it's kind of lengthy. Okay, so g of x is actually discontinuous, it is discontinuous. Okay, and this f of x, okay, here I'm talking about f of x, okay, because see, f of g of x, that means what, you are having two different functions, one is f, okay, one is f of x, okay, one is f of x, then another is g of x, okay. So in composite function, in case of composite function, I've replaced this x, okay, with this g of x, yes, right. So here this f of x is discontinuous at point, you can take p, okay, so here it is discontinuous, okay, then that means which point will be making you some trouble, which point will be giving you some trouble, g of x is equal to that particular p point, right, because here x, okay, when x is at, okay, when x is at this point p, it is actually discontinuous, okay. Here what you have done, you have replaced, okay, in case of f of g of x, okay, you have replaced x from f of x, so you have replaced x from g of x, so that means when you are equating this, you will be getting like x is equal to g of x, right. So that means where this f of x is discontinuous, in that point if you are actually equating with this g of x, then that will be your doubt point, okay. So I know like about 60 to 40% only will be clear now, after one sum it will be all clear. Okay, so the sum is, okay, so what you have got is, you have got this color is same as that color, na? Okay, I've got f of x, okay, f of x is 2 divided by 2x minus 1, then g of x is equal to 2 plus x divided by x, okay, then find points of discontinuity for f of g of x. Okay, so this is what the question is, they have given you f of x and then g of x. Now what they are asking is, they are asking you the points of discontinuity for the composite function, which is f of g of x. Okay, so how will you calculate this? first take g of x. Okay, first you have to take g of x. So g of x is equal to 2 plus x whole divided by x. So just by looking even you can say that x should not be equal to 0. Okay, x the point where x is equal to 0, it is discontinuous. Okay, it is actually what is it? It is infinite discontinuity. So when it is actually x is equal to 0, it is discontinuous, right? So here this is a point of discontinuity. Continuity. Okay. Then, okay, so you leave this g of x. Just now we have done with this g of x. Still, you will be coming with some other point that we will be saying. Okay, for now, okay, till now g of x is completed. Next is f of x. Okay, which is this value, right? So you know that for the case of f of x, this denominator should never be not only for this, for any rational function. Okay, for any fraction. Okay, the denominator should not be equal to 0. Yes, right. So then that means it should be 2x minus 1 should not be equal to 0. Then it will be 1 by 2. So x should not be equal to 1 by 2. So that means here x should not be equal to 1 by 2. You got x. And what did I say over here? I said that you have to equate that particular point where it is discontinuous. Where f of x is discontinuous, that point should be equated to g of x, right? So this point is where this is the point where f of x is discontinuous, which is 1 by 2. So you have to equate it with g of x. Okay, so let us equate it. So it will be 1 by 2 is equal to 2 plus x whole divided by x. Okay, so just cross multiply, it will be x is equal to 4 plus 2x. So put it over here. So it will be yes, so x is discontinuous minus 4. Okay, so x is discontinuous at minus 4. So you got all these values. This is how we are going to do. So the points of discontinuity, just now we have checked it all clear. Okay, so I can write a little bit neater, that is 2 plus x by x is equal to 1 by 2. Okay. And x is minus 4. Okay, so what concept do we have next? Single point continuous function. Okay, so next is single point continuous function. Very easy. Okay, see, function which are continuous at one point are defined everywhere. Okay, are undefined everywhere. Yes, so single point continuous. Now in our book also they have given, right, they will be given like, what is this known as piecewise function. Yeah, they will be giving piecewise function where there will be two different equations and one will be equal to some sort of constant and next will be x is not equal to one constant. Like this questions are there even in our NCERT book, right? So this is actually also such sort of thing only. Okay, this is also one such thing which is single point continuous function. Okay, so you are just checking at one single point and then you have to determine whether it is continuous or it is not. Okay, so for an example, okay, so yeah, for an example, let us have like f of x. Okay, x and 0. See, for this function, okay, so for this function, whenever q belongs to, you can take, what shall we take? We can take integers. Okay, and whenever x, it does not belong to q. Okay, sorry, integers. Okay, so here in order to determine, okay, something is happening with my mouth. In order to determine whether is this continuous or not, the only thing is that this, okay, this should be equal to this. Okay, in this case we are talking, then that means x should be equal to 0. If it is equal, then it is continuous. If it is not equal, then it is discontinuous. This is what single point continuous function is. Okay, so here to be continuous, x should be equal to this one, so which then it will be continuous. Okay, so I think still one more concept is there. Intermediate value theorem. Okay, intermediate value theorem. This theorem is a little bit bigger, okay, than the concept that we have, okay, in our portion. So we are just going to check only one point. The one point in sense, one point of this theorem. Okay, one particular point only we are going to check. Intermediate value theorem. So actually what it says is, first I'll say in my English, then we will come to the theorem's English. Okay, so you are having an axis. Okay, here let us say that you have got two different points. You have got two different points where one point is positive, okay, and another point is negative. Okay, so if in case you have to connect, okay, or this point has to move there, okay, like that you can keep to this point, or you have to connect this point to that point, then at least one root or x value will be there. Okay, root or x value will be there. Okay, I know my English is not that good in explaining this one. So a function f is continuous. Okay, and note, yeah, a continuous function. Okay, there is a continuous function. Okay, there is a continuous function, and that function's graph is this one. Okay, it possesses continuity from the interval of a comma b. Okay, then f of a and f of b should possess. Wait. Okay, so here I have written the definition. See, a function is there. Okay, first there is a function. That function is actually continuous. Okay, that function is what? That function is continuous, and then you have taken two different points in that function. Okay, there is actually continuous between these 2 points only, which is a comma b. Okay, so in terms, you have to say in terms of functional, and how can you say? You can say in terms of f of a and then f of b, you can say, right? Okay, and they have clearly said that f of a and f of b are actually having opposite signs. Okay, and this function is continuous from the point, okay, a to b. Okay, so and they also said that these two should be having what? Opposite signs. Okay, and we know that in an interval, okay, in an interval, the least number should be written in here and the biggest number should be written here. So if it is having negative sign now, so then a is the thing which is going to have negative sign. Okay, so it is going to be f of a, which is actually having a negative sign. Okay, this point. Then there is another point which is actually here. Let us keep it like here. So which is f of b. Okay, which is actually having positive sign, and the line will be like this. Okay, for an example, if you can keep the line will be like this, and let us keep like the y-axis line is like this. Okay, y-axis line is like this. This is what the y-axis is. This is what the x-axis is. Okay, and this is what those 2 points are. Okay, so that means in one of its solution, okay, one of its solution of this function, there will be at least one solution where f of x is equal to 0. Okay, where f of x is equal to 0, and note, okay, note, this should be continuous. Okay, this function should be continuous. If it is not continuous, then it can jump at this point. Then if it jumps at this point, then it will be not equal to 0. Okay, what is f of x? F of x is equal to, okay, f of x is equal to y, right? So y should be equal to 0. Okay, so what is y? Y is actually, what is the definition of y? Y-axis. Y-axis is the distance from the x-axis. So this is what the x-axis is. Okay, so this is what the x-axis is, and the distance from the x-axis, the point actually lies on the x-axis itself. So that means there is no distance on it from that point to that x-axis. So that means totally y is going to be 0. Okay, so this is what this intermediate theorem says. Okay, intermediate value theorem says, which means you'll be having at least one value whose value is 0. Okay, whose value is 0. So that's it for today's video. We will be meeting in another amazing video. Till then, bye bye.